Coral reefs are created over millions of years, creating structures scattered all over the globe. And they are essential not only for our economy, but for our health and for all planetary systems to really function together. They are essential for life below water, but also for life above water. They're just not beautiful. They help us sustain life on Earth. In this session, co-hosted by the Exponential Roadmap Initiative and Google, we will hear about Calling in Our Corals, a digital platform founded by Google Arts and Culture Lab. And it's supporting scientists to understand biodiversity in coral reefs and help with their reconstruction. So, I first like to start by introducing Jennifer Koss. She's director of the Coral Reef Conservation Program at the National Oceanic and Atmospheric Administration, also known as NOAA. So wonderful to have you with us here, Jennifer. You are joining us via Zoom. Let's just get the sound check, see if we can hear you. You're muted now, but you will be joining us in a bit. So. Okay. You're okay now? Great. So you have a few minutes for a keynote before we move on with this program, so you have our full attention.
Very glad to be here. I hope you can hear me now.
Yes, yes we can. Thank you.
Wonderful. Are we starting now?
Yes, please. Go ahead.
Okay. All right. I will take it away. I'm Jennifer Koss. I'm the director of NOAA's Coral Reef Conservation Program. Very happy to be participating. And I've just got a few slides to share with you to sort of set the scene for the rest of what I hope is a very dynamic and informative panel session for everyone. So I'm going to attempt to do that.
Jennifer, could you please share your slides?
Yep, I'm getting to that right now.
Thank you.
Here we go. Can you see that?
In a second, not yet. It's coming on.
Okay, great.
Yes, we can see them now. Perfect.
Wonderful. Okay, I'm going to jump right in then. Just to give people a little bit of a setting in terms of why corals are so essential for the world's population and the myriad ecosystem services that they provide. Right now, what we know about corals is that in and amongst the corals themselves, there's over 2 million species. Some people like to call corals the rainforests of the world. I think the more that we explore coral reefs, it's going to be the other way around. Rainforests will be considered the coral reefs of the world. We're going to exceed our understanding of biodiversity in coral reef areas to be greater than what is in rainforests right now. Right now, there's a little bit more than 500 million people who are in some way dependent on coral reefs, right about that 500,000 mark in terms of millions of people. They are 100% dependent on corals, either for the lands that they live on, their livelihood, their source of protein, for coastal protection. So without these coral reef areas, we would see a lot more of people essentially having to migrate from their homelands. And we're already seeing that happen in Kiribati. And just most recently, I saw an article in Panama, some of their coastal island areas. Those people are being moved off to their islands onto the mainland of Panama because of sea level rise and loss of that coral reef infrastructure around those islands. And people just largely depend on corals, not just even so much for those economic and basic life needs, but also for the cultural and spiritual aspects of what corals provide. For Native Hawaiians, they have a life history that's done through an oral fashion. It's called the kumulipu. And literally the first living thing that they talk about in that chant is the coral polyp. It's the basis of the Hawaiian life and the basis of the archipelago as they understand it. So incredibly important for spiritual, cultural, and then basic needs of people all around the world, primarily in our tropical areas. I talked a little bit about coastal protection. We've done a lot of studies with US government resources to understand the coastal protection values of coral reefs around the United States. And we understand that a healthy, robust reef ecosystem can absorb up to about 97% of a wave's energy, which is incredibly important if you think about hurricanes, tsunamis, typhoons, anything that causes a big disruption in the wave energy, having those coral reefs offshore and slightly inshore really breaks up that energy that can be incredibly destructive during high energy events. And that's really been demonstrated recently through some studies that our US Geological Service has done and has now been factored into the way that our federal emergency management system is working. Even at the highest political levels, we're seeing our military, our environmental and emergency managers really thinking about natural infrastructure to protect coastlines rather than the traditional hardened infrastructure, which can ultimately be more deleterious than other ways to protect coastlines. So our understanding currently is that $1.8 billion in flood protection occur in benefits for the United States. We haven't had a chance to extrapolate that out around the world, but that's an enormous amount of coastal protection that Mother Nature is essentially providing us for free. An untapped area of research, which I really love for us to get into, is that of pharmaceuticals. There's been several different compounds found from either the corals themselves or animals that are associated with coral reefs that have been used in the biopharmaceutical industry, from treating asthma to curing cancer to reducing inflammation. And the more reefs that we lose and the less we have a chance to understand what's there, the cure for the next disease could be in coral reefs. So there's an untapped resource there that's just starting to happen. And I definitely would love to understand more about that if anybody has good ties into the pharmaceutical industries to understand the magnitude of those investments and what could be ultimately gained from pharmaceuticals. Just a few more statistics here for you. These are a little bit outdated. NOAA is undergoing a process to update all of these economic values for US, but roughly in the United States, $36 billion in tourism, 172 billion in global services. That's taking all of the ecosystem services into account in one figure, and then just breaking out for the United States, 100 million in US recreational fisheries and another 100 million in US commercial species. It's estimated that 25% of all marine life spends some portion of their life cycle on a coral reef. So if they were to go away, it would have cascading effects above and beyond just the loss of that structure in those particular areas. So unfortunately, the number one impact to coral reefs right now is climate change. It's been a growing threat over the past couple of decades. What happens with corals is when waters reach an abnormally high temperature over an extended period of time, the corals bleach. And what that means in terms of understanding what's going on is the corals have these algae in their tissue that are symbiotic, and that algae is what gives corals their color. When the corals become stressed because of prolonged exposure to too high of a heat, they spit out that algae, and what you're seeing is that skeleton underneath. It's important to know that a bleached coral is not necessarily a dead coral. If the temperatures come down, the corals can re-recruit those algae, but they've been severely stressed when that happens. If the bleaching period is too long, that coral will ultimately die because it can't feed. Corals get most of their energy from the symbiotic algae, and they do a little bit of feeding on their own, but they can't feed enough on their own to make it through a prolonged bleaching event. Another byproduct of climate change is ocean acidification. And put in simple terms, the coral can no longer net accrue more skeleton to make itself bigger. With increased acidification, the coral ultimately can't make that skeleton and sustain itself. And so you see some bioerosion of the coral because of ocean acidification. And that bioerosion happens through normal processes in terms of the types of fish that like to feed on it, and then just erosional processes in general. So kind of a two double hit there from climate change that makes climate change absolutely the number one stressor and loss of coral cause right now. And speaking of bleaching, we are in the midst of the 4th global bleaching event. Waters are in the Caribbean and Florida are warmer now than they should be. This happened last year as a byproduct of El Nino, and we saw bleaching 4 to 5 weeks ahead of when we normally see it when we're in a bleaching cycle. And this is a product of our NOAA Coral Reef Watch program. We provide forecasts and warnings so that managers, if they want to take any sort of action for their coral reefs, they're able to do it. We can give them enough lead time to know how to do it. And some of the actions that people can take include closing areas to fishing and diving to decrease stressors. For those of us that have coral nurseries, we're able to move those nurseries into colder, deeper waters. There have been some advents in physically shading corals, producing biofilms on top of the water just to reduce the light stress. And I believe some other folks are even noodling around with pumping up colder water onto coral reefs. These are all obviously expensive and labor-intensive activities, and scaling these types of interventions up on a scale of something like the Great Barrier Reef is obviously astronomically expensive. So it's in our best interest to try to figure out how to reduce greenhouse gas emissions and do everything that we can to make sure that coral reefs have a fighting chance to persist into the future. But I did want to say it's not all doom and gloom. This is a time series of photos that we took in the Virgin Islands last summer. And you can see there in May of 23, this is a healthy head of coral, almost 100% bleached in October, and then almost 100% recovered in March. So there's enough resilience and innate strength in the system that if we take some additional interventions and wrap our heads around climate change, we have every reason to think that corals should and will persist into the future. But the time is very much now to make those interventions. We can't not make active endeavors into restoration. We used to think we could just ameliorate and mitigate local stressors, and then the corals would have enough reproductive capacity and innate resilience to withstand the worst of what climate change was bringing. But now we understand we really need to be actively intervening on behalf of corals. So we're going to head into what I hope is a great panel. And what I really want you to take home is that coral reefs are severely threatened, but not doomed. Stopping further declines is no longer enough. Replacing what we've lost is where we are in the United States, especially in areas like the Caribbean and South Florida, a little less needed in the Pacific. Those reefs are in better shape. And the time is to act now. Those interventions are being researched. There's a lot of really exciting international efforts underway. The advent of AI, greater opportunities to share data across shared platforms is coming online. And there's a real banding together of scientists and universities and governments that I've never seen before in the 20 years that I've been doing that. So I have every reason to think that with a few more smart people who are thinking slightly outside the box of the average coral biologist, that we stand a good chance of recovering these incredibly valuable ecosystems. So with that, I think we can kick off into the panel.
Well, thank you very much indeed, Jennifer Koss. You're going to have a little bit of an intervention here in between before the panels. So stay with us. You'll be back on Zoom. And thank you. I'm very happy to introduce Clare Brooks, who is program manager at Google Arts and Culture Lab, and you have a presentation here to share with us that is part of this fantastic scheme to save the corals. And it's an interactive presentation, and we can't wait to see it. So the floor is yours.
Thank you very much. And thank you to Exponential Roadmap and We Don't Have Time for hosting me here today. And also thank you, Jennifer, for your really insightful introduction. I'm Claire, and I work at Google Arts and Culture. We're a non-profit team, part of Google, who work with museums and cultural institutions globally to give people access to art and culture online. Within this team, I lead a program that focuses on sustainability, ecology, the environment, and our aim is to raise awareness and inform on climate science by creating meaningful bridges between scientists, artists, institutions, and policy organizations. We have two main focus areas. One is since 2019, and in collaboration with the UN Climate Change, we've worked with artists and scientists to interpret complex climate data as part of our science and artist residency, Heartbeat of the Earth. We also have a hub online on our platform and app called Culture Meets Climate that enables our partners that include NGOs, intergovernmental, scientific, and cultural institutions such as NASA, UNEP, and the Smithsonian to create tangible and engaging stories about our planet. Themes range from ecosystems to preservation and celebrate our relationship with nature and communicate expertise to global audiences. One of the projects under our Heartbeat of the Earth program focuses on coral reef restoration. To echo Jennifer's introduction, coral reefs cover only 0.1% of the ocean's surface, but they host 25% of all marine species. So it's really fundamental that we scale up our efforts to help preserve and restore them, as they're in decline, as we've seen, due to overfishing, disease, coastal construction, and heat waves. The UN has declared 2021 to 2030 to be the decade on ecosystem restoration, and we want to support these efforts too. There has been progress in finding ways to adapt, mitigate, and restore. Emerging research actually shows how eco or bioacoustics, which means the natural sounds that characterize an ecosystem, can help us better understand reef health. A healthy reef is actually incredibly noisy. You hear fish sounds like pops and chirps and whistles, which we'll go into in a bit. And that soundscape can tell us how healthy a reef is and also which reef is in decline. I've actually added a screenshot here on the right of a paper that shows the habitat degradation negatively affects auditory settlement behavior of coral reef fishes. And that just means that we can learn about the state of our coral reefs by listening to them and comparing soundscapes between damaged, restored, and healthy reefs to show their reef health. And now I want to introduce you to a further scientific discovery that takes these sounds and repurposes them. A few years ago, we were approached by Professor Steve Simpson, a marine biologist at the University of Bristol. And together with his team, he discovered a way to accelerate the rate of reef restoration. Actually, anyone in the UK can watch an episode on the BBC from Our Changing Planet that really shows Steve's work there. And when working with scientists to repopulate the reefs with native coral larvae, he tried something quite extraordinary. Sounds of noisy, healthy reefs were added to restored reefs, and the larvae was attracted to that sound. So we can say it's like a party on the sea. There's like all these sounds of fish from these like restoring reefs, and these coral larvae came spiraling down as they were attracted to that sound. I mean, it's pretty amazing. And how do they achieve that? Well, they recorded the sound of healthy reefs nearby, and they put these hydrophones in the restoring reefs that emitted that sound to that area. So they're calling the life back in. I wanted to show you also what a reef restoration looks like over a 3-year period. So on the left here, you see a reef restoration in Indonesia. You see the reef stars here, and the species will latch onto these reef stars. And on the right, you see a reef that's been restored after 3 years, and it's quite formidable to see. But of course, there are challenges to having all of this audio available. So with this discovery, they also had too much audio to actually monitor this process, because it's also a manual process, and they just don't have enough people to do this. So there's also another thing, is that means that many sounds on the reef have been remain undiscovered. So together we decided to create something that would ask people around the world to become a listening collective, and that would help track information and discover new sounds. But what is this platform? So we created Calling in Our Corals. It's an online platform that brings together marine biologists, creatives, programmers, and citizen scientists together to monitor coral reef health. And this was launched in April last year. It asked online users to listen to this audio that we have and help track the important information and discover new sounds from these reefs. And I'm about to do a live demo, actually, of the platform for you, where we get to meet Steve and Mary, the two marine scientists who worked with us on this initiative. The online platform can be accessed actually by you online via the Google Arts and Culture platform online or app. It's called just Calling in Our Corals. You can search for it and you'll find it. So I'm just going to launch the platform. Are you seeing the platform? Just a second. Great. Thank you very much. So with this platform, in just 3 minutes, we can help marine biologists attempt to bring life back into coral reefs. So here we're going to take you through to the Philippines. You can actually contribute to more sites if you like. There are about 12 sites around the world that you can contribute sound to, tapping to. And we always ask you to use headphones. It's a better experience with those. So here you're hearing sounds of a marine protected area in the Philippines, and that's what a healthy reef should sound like. You can hear croaks and pops from the fish. And next, this is what a sound from the nearby reef that's been heavily overfished. This is what it sounds like. You can hear snapping shrimp, but that's about it.
Hi, welcome. My name's Steve. I'm a marine biologist from the University of Bristol in the UK. My whole research group have discovered that when we listen to the sounds of the reef, we hear biodiversity, animals that live deep inside the reef, but there are too many recordings for one person to sit down and listen to. And that's where you come in.
So we're going to do some training on what reef sounds like. Steve's going to take us through what a spectrogram looks like and how you can hear these different fish, and then we'll actually go into a quiz.
So what does a reef really sound like? If you're lucky, you might hear the song of a humpback whale in the distance. Here's a spectrogram of that song. You can see in the picture the notes that the whale is singing. On the reef, you've got thousands of species of fish that are producing pops and chirps and croaks as they communicate with each other. And in the background, you've got the snapping shrimp, each making little popping sounds that together make the reef crackle.
So here I'm going to turn to the audience actually sat to my right, because I'm going to do a little quiz. Hands up for who thinks this sounds like a motorboat. No hands. Who thinks this sounds like bubbles? I have 4 hands. And fish? 2 hands. Okay, I'll go for bubbles. No, it was actually fish. Well done. Next, I don't know if you can hear this sound. Who thinks it's a crab? 2 hands. Who thinks it's a motorboat? 1 hand. And who thinks it's snapping shrimp? Okay, most people. It was snapping shrimp. Well done. And next, I'm going to do these a bit more quickly, but these sounds are quite extraordinary. So this is also a fish. And this, when I first heard this, I thought this was divers, and in fact, it is a fish. And this, I think, is pretty simple. It is a motorboat. And this one is incredible. I thought it was shipping when I first did this, and it's actually a fish.
For the first part of this project, we're going to go to the Philippines, and I'd like to introduce you to Mary, who's been working in the Philippines for the last 3 years.
Welcome to the Philippines. My name is Mary Stipo and I'm a marine ecologist. And over the last year, I've been putting down sound recorders in 6 marine protected areas and adjacent heavily fished areas to compare them in order to get a better understanding of the effects of fishing on marine soundscapes, which are an important indicator of coral reef health. For each of these sites, the sound recorders are put down for 24 hours. So now we have hundreds of hours of recordings. But here's where you come in. We need your help and the help of others like you to form a listening collective. Your data will then be used to train computers to listen for fish sounds automatically. So even 10 seconds of your time can help to contribute to cutting-edge biodiversity research and supporting better protection of coral reefs. You might even be lucky enough to hear fish sounds that no one has ever heard before. So have a listen and tap when you hear a fish sound.
Here we get some extra training on how to look for the fish
So
sounds
let's have a look
on the
at exactly
spectrogram.
what you need to listen out for. So let's start the experiment. So what you're seeing here is a visual representation of what you're hearing. It's called a spectrogram. So in the higher frequencies you can see here, it's the snapping shrimps, the kind of sizzling sound. And you can see down here in the low frequency range, that's the fish sounds. So the louder it is, the more pink it is. And if it's quieter, then it's blue. So this is where you want to be looking out for your fish sounds.
And here we get to finally contribute. So as Mary was showing us, we can identify the fish sounds visible in the spectrogram at the bottom, so they turn up in pink. But we can also hear them, so sometimes they don't actually turn up on the spectrogram, so it's also a good thing to have your headphones, the volume up to really hear them. And then we click when we hear the sound of a fish. Here we can select a location. So these are different sites around the world. We have Indonesia, Australia, Philippines, Kenya. There's even some in Belgium. There's also Sweden. I'm going to choose Indonesia today. Give it a few moments. I'll choose a different clip then. Maybe it's buffering. Let's choose Kenya. There's something happening with the Wi-Fi. I think it's either buffering or something's happening with the actual sound, the audio coming up with the spectrogram. But you can do this at home from your devices online on our platform. Just Google calling in our corals and it will come up. And yeah, we'd love for you to contribute to this and start listening and click when you hear a fish sound. So what were the results? That's really important. A year on, a bit more than a year on. Well, visitors listened to over 400 hours of reef audio that would have normally taken months for scientists to analyze. And by crowdsourcing this activity, we were also able to create a library of new fish sounds. And excitingly, last Thursday, we announced the results of this initiative. And Ben Williams, who is a marine biologist at the University College of London, and a team at Google Research and Google DeepMind, took 57,000 reef sounds from 12 different countries and trained an AI model. And the result is an AI model called Surf Perch. It's an AI-led system that is faster and easier for marine scientists to find answers to ecological questions. Surf Perch is going to help researchers worldwide with unprecedented access to data, faster processing times, and labeling of species. And it's available open source on GitHub and Kaggle, as you see here on the right-hand side. and it has a tutorial. There's also a research paper that's currently underway. And also, the calling in our corals contributions help to fine-tune this model and discover new sounds. Lastly, our first trial, combining calling in our corals with surf perch, has already revealed a difference between protected and unprotected reefs in the Philippines, for example, and also restoration outcomes in Indonesia. We'll go into this in more detail with Ben, who's going to come along on the panel with us in a minute. And you can also listen and help still and contribute to the platform, because we've got new audio on the platform so that we can help further train the model as well. So wanted to thank you so much for listening to this presentation, listening to the fish and the coral reefs, and also hope that you'll listen to some fish in the future for us to help protect coral reefs.
Well, thank you so much, Claire. That was brilliant. Please have a seat, and we'll have some more people join us. So, Jennifer Koss, please join us again on Zoom. And you might need a new presentation if people jumped into the broadcast. You're Director, Coral Reef Conservation Program, National Oceanic and Atmospheric Administration. Great to have you on board. And we also have Ben Williams, that Claire just mentioned. He is PhD student on AI for coral reef conservation and restoration at the University College of London. So welcome, Ben. And we have also Ian Enochs, a research ecologist at National Oceanic and Atmospheric Administration at the Atlantic Oceanographic and Meteorological Laboratory. So, fantastic panel to discuss this topic. I'd like to start with you, Jennifer. What are you already noticing when it comes to economy and the social situation as an effect of the coral reefs suffering already?
As we study reefs more, we have much more firm understanding of those economic ties and social and cultural ties to coral reef areas. So I briefly mentioned earlier on, we're seeing, unfortunately, some lower lying islands that are needing to be evacuated, and those people moved to other areas. We're also seeing a greater articulation of what those social and cultural values are to coral reefs and why it's important to conserve and restore them, and also incorporate traditional ecological knowledge or local and indigenous knowledge into the management of those reefs. People have lived in harmony with reefs for thousands of years, and incorporating the understanding of the cycles of coral reefs and fishing and the impacts of land onto corals is becoming much more of a topic for holistic conservation, not just trying to conserve the corals independent of the land masses. So you're seeing that echoed in a lot of international policy with the recent 30 by 30 efforts, 30% of land effectively managed and 30% of marine resources effectively conserved. So there's a much greater understanding and much more knowledge about what those ties are, and we're seeing increased investments into conservation efforts.
Thank you, Jennifer. Can you give us some examples of how the corals are reacting and acting? How are they adapting to the hotter situation?
As I said before, we're in the 4th global bleaching event. So unfortunately, we're seeing bleaching happening on a more recurrent, faster basis, and the bleaching events themselves are more destructive. Corals have bleached for millennia. Before, the corals would bleach, and then it would be decades to a decade, 2 decades before the next bleaching event would happen, and the corals would have enough time to recover in between those events. Now we're seeing those events pile on top of each other, and the corals just aren't having enough time to fully recover. But even with all of that mortality of corals, we're also seeing that some corals are resilient to these thermal events, and those are the corals that we are using to breed and propagate and do restoration efforts with. So we're understanding the resilience of corals all around the world by sharing data across different platforms with managers, with governments, with scientists, and really trying to harness that innate resilience that some corals have to be able to use them for future mass restoration efforts.
Thank you very much, Jennifer. I'm turning now to you, Ian. Could you tell us briefly about your background and also what you see in terms of impact of climate change on the corals?
Certainly. Can you hear me all right?
Yes, we can.
Wonderful. I'm the lead of the coral program at NOAA's Atlantic Oceanographic and Meteorological Laboratory in Miami, Florida. I'm the principal investigator for monitoring the impacts of climate on reefs in the Atlantic and Caribbean, principal investigator for monitoring climate as part of Mission Iconic Reefs, which is the largest U.S. reef restoration project to date. And my research focuses on the persistence of reef habitat, that complex structure that provides homes to countless species, along with goods and services that protect our coasts, provide food for families, and create billions of dollars of economic value annually. And as Jen mentioned, this habitat is imperiled from global warming and bleaching, from ocean acidification, from coral disease, from poor water quality, and from overfishing. And so my team is working to monitor reefs and understand the impacts of global change, to identify mechanisms of resilience and develop technologies that can be used to flip the trajectory of reef decline. As Jen also mentioned, we are currently in the 4th global bleaching event. Think about that. Bleaching and corals are dying across the planet. This year, as summer is just starting here in Miami, and in Florida, we are already breaking temperature records. And so we have a sense of urgency, and we are worried about what is to come in the months ahead.
Thank you very much, Ian. So you saw Claire's fantastic presentation. What reflection do you have on this program? What solutions it can bring?
So one of the things that really resonates with me and something that I've been thinking an awful lot about recently is the matter of scale. Coral bleaching was once a really small scale and really obscure phenomenon. And it was only really discovered about 40 years ago. So in living memory. And now, again, we are in the 4th global bleaching event. And reefs are spread across hundreds of thousands of kilometers across our planet. Much of it is hidden by water and waves. And if we hope to monitor, manage, and understand and protect our reefs, we need technologies. We need technologies like this one that are scalable, that allow us to rapidly assess reef health and persistence. And so ultimately, I am encouraged by these partnerships that have led to multidisciplinary teams attacking these challenging issues. We are in the 11th hour of this reef catastrophe, and it is not too late. And it's the time now to do something about it.
Thank you very much, Ian. I'm turning now to you, Ben. In terms of potential solutions and also the practice here of listening to the reefs, how can this matter?
Yeah, well, firstly, thank you for having me here. And I think Claire highlighted so brilliantly how we can learn about the state of reefs by listening to them. So on a healthy reef, we have this rich and diverse soundscape, all these different fish sounds. But on a degraded reef, that soundscape is greatly diminished, and we hear far less complexity of the acoustic soundscape. So there's a lot we can learn about those reefs, and it's not just us who likes to do that, but it's actually the juvenile fish and corals and other invertebrates that in their first few days of life, they drift out into the open ocean. And then after they've developed, a week or two later, they return to the reef by listening out to it. So having a healthy soundscape is an important ecosystem function in its own right as well.
Thank you, Ben. What would you like to add when it comes to AI and the possibilities that AI holds in terms of saving the coral reefs?
Yeah, so there are so many ways that AI can support coral reef conservation. And of course, my own work has been leveraging it to support us in understanding acoustic data. So I think Ian touched really importantly on the scale that's needed to monitor these reefs. So the gold standard is still that we have an expert team of divers on the water who are writing down everything they see and taking pictures of small areas of the reef. But that's really hard to scale to a large amount of places over repeated surveys. Whereas we can turn to technology, so things like low-cost acoustic recorders that we have now, we can scattergun these across a reef. We can leave them down for months on end, collecting a huge amount of data on the pulse of the reef. And the last bit of that we haven't been able to make much progress on yet is the automated analysis of that data. up until very recent years where we've been leveraging artificial intelligence to do that for us. So we can do this with acoustic data, we can do this with image data from coral reefs, and there's also other approaches. We can create predictive models of what reefs might look like in the future, or even where we're finding them and what state are they in now. So those are many of the ways that AI can support coral reef conservation and restoration, but crucially as well, as Jennifer mentioned, getting a grip on greenhouse gas emissions is key. That is the #1 threat to these habitats at the moment. So AI can help us understand how to implement conservation, but broad picture, we also need to get a handle on global warming challenges.
Indeed. So, Ben, how was surf perch trained and how is it already benefiting scientists?
Yeah, so to train surf perch, I was fortunate to join Perch, which is Google DeepMind's in-house bioacoustics team that they have. I joined on the student researcher program, and we started by first assembling this large data set of expert annotated coral reef sounds from 12 countries, 16 different individual locations. And we used this to train our model to recognize different reef sounds. However, we actually found that this was still a modest data set compared to other acoustic domains. So bird bioacoustics, for example, which the team had worked on, had over 3 million recordings that they could work with. So the secret sauce, if you will, to developing surf perch was actually mixing together our reef sound with the recordings of birds that were available, and also entirely unrelated audio. So things like fire engines, dogs barking, car noise, just to give this model the essence of what sound is, what bioacoustics is, and then what do reef bioacoustic recordings sound like. So this gave a surf perch that can be rapidly fine-tuned on new sounds. And the last piece of the puzzle that we need is finding those new sounds from any given data set. And that's where we've been working with calling in our corals. So there's a wealth of information from a number of countries now where we've tested this out on a preliminary set of data, taking sounds that citizen scientists pulled out from recordings in the Philippines, in Indonesia, in Australia, to start monitoring differences between protected and unprotected areas, or healthy, degraded, and restored reefs at each of these. So we've done a preliminary trial on those three, and it's working well. And actually, very recently, I've run this on a full scale, 6 months of raw audio from Indonesia across 18 different sites. We detected over 100,000 different fish sounds across this data set that were based off those sounds that citizen scientists found. So there's more to come on that work in the future. We're expanding globally, and anyone's help will be absolutely paramount to success of this. We need more people listening to this data and giving us those annotated recordings that we can then fine-tune the model with for each new location in the world. So absolutely check out the Calling in Our platform, Calling in Our Corals platform that Claire shared with us.
Well, thank you so much, Ben. It's a great platform. Claire, thank you again for your presentation. In terms of synergizing efforts, how can we do this and why is it so important?
So at Google Arts and Culture, from our perspective, we put science and technology in people's hands through through our platform, through culture. And obviously we're faced with very hard facts, complex data, very complex reports. So it's a great idea to distill those reports and make that complex data more tangible for people. And how can we do that? Well, we collaborate with artists, we collaborate with creatives to create platforms that engage, that are simple to understand, to use, but also kind of come full circle with solution ideas and, like, you know, kind of giving people agency and empowering and enabling people to make more sustainable choices, for example, you know, through expertise from our partners. So it's really important that we synergize efforts between different sectors such as policy, technology, science, and culture. So yeah, that's our platform.
It's a beautiful, beautiful marriage of these different aspects of society, indeed. So, Claire, what is the potential next steps for this?
So these types of projects, so at Google Arts and Culture, we innovate all the time with partners. So, you know, the expertise comes from our partners. And so it's, you know, Ben mentioned Perch, for example. So Perch is a project that was, so it's an AI model that was launched recently. And for this project, as Ben said, it helped us train this new AI model. So as part of our next steps, it could be that this is actually quite usable to scale, you know, to scale to different ecosystems, perhaps even different biomes, who knows, you know. So for us, it's a really interesting kind of juncture here where, you know, we have this template that we could perhaps use again and again for different different things, different species, etc. And so on this idea of scaling, though, we also are heavily influenced by our partners. Our partners would decide on what is the most important thing to innovate on right now. What should we be focusing on right now? And so, yeah, we leave that to their inspiration and their ideas.
It just sort of opens up your mind here. It could infinite possibilities, right?
Absolutely, yeah.
So turning to you now, Jennifer, do you have any more examples of conservation and collaboration that you'd like to share here?
Yeah, building off of what we've already talked about, Ben mentioned it briefly. Not only is there machine learning in interpreting the sounds that are coming off of reefs, there's also machine learning on visual images. And I think what's really important is that those individual efforts don't stay siloed, that we share our learning and we share platforms and we sort of democratize the science that we're doing in order to understand how all this information can be used for management purposes. So having partners like Google who have that huge computational force and are able to defray some of the public sector costs that are going into this is enormously important. I think at the global level, we're very much all in it together, but making sure that that information is free and open and the algorithms that are used to interpret the data can be used in other areas of the world in a way that's not expensive and doesn't require a lot of technological savvy, the better off that we'll be, because the average coral reef manager doesn't have time to read a ton of peer-reviewed articles or understand all of the different technological advances that are coming online. They need easy access to information so that they can make the decisions that they need to at the local level. So I'm really inspired and want to follow up more on the acoustic end of things, because we're making really good strides on the visual end of things as well.
Well, thank you, Jennifer. Ben or Ian, would you like to add?
Yeah, I'm happy to come in. And I think there's certainly so many other ways that citizen scientists can contribute to this work as well. There's loads of projects out there. It might be annotating image data. That's a big one. So we want to understand what are the different coral species, the growth types, things like that we're seeing on the reef. And these are always huge collaborative efforts. You see there's academic institutes, increasingly industry partners. I work very closely with Mars, who support the world's largest reef restoration program. And then also private individuals as well contributing to these. So there's so much collaboration that I think can really be a source of good and push AI into ways that it can help the environment as well. I think with the kind of unprecedented scale of a challenge facing the environment and global climate catastrophes happening at the moment, that the unprecedented pace of AI development means it's going to be a really pivotal tool in solving these challenges.
Thank you, Ben. Ian, what would you like to add?
Yeah, I'd like to, echo what some of my colleagues here have been saying, is that the collaboration, the intersection of engineering, of technology, and of restoration is so critical and so exciting right now. We are facing such a large scale catastrophe. And really at the same time, these technologies are emerging to meet this catastrophe head on. So the intersection of opportunity and a challenge. And I think that's very exciting in the face of what we're dealing with.
Well, thank you, Ian. A question to you and also to the other distinguished members of this panel. What do you need to be able to speed this up and scale these solutions even more? I mean, Google obviously is a big factor here in making this happen, but what else can you need? Get more of policy changes, well, what else?
Well, the exciting thing is that we have a bunch of different technologies that are being developed. We have these tools that we know are working. And so scale is what is important. Implementing these at a scale that is currently not used traditionally in restoration and ecology. We know that this can work. We know that infrastructure projects happen on a huge scale. Billions of dollars are pumped into protecting our infrastructure. Coral reefs are our natural infrastructure. As we've seen, they provide billions of dollars of protection on a yearly basis. And so what we need is for humans to rise to face this challenge head on at a scale that is ecologically meaningful. That's what we need.
Well, thank you. Jennifer or Ben, would you like to add? What else do you need to create more speed? Jennifer, go ahead.
Sorry, I would echo what Ian said. It's greater knowledge of what we do as humans to the planet, changing our behavior in some ways that probably will require policy change, and then employing these new technologies, hopefully with investments from both the public and private sector, because these will be costly, but in the end, very worthwhile investments.
Thank you, Jennifer. Ben.
Yeah, I completely agree with what Jennifer and Ian have said. And I think what's key is being able to think long term in terms of policy, which perhaps we don't see as much as we should. And also seeing many of the contributors, not always thinking about this from an individual basis, but business and industry, how they can help, and ways that we can make it competitive to actually be contributing to the environment rather than a kind of burden that they have to take on and could hold them back against their other goals. So I think that's going to be really key in motivating the policy, the industry drive, alongside the individual contributions. I think those three are really needed to see solutions to all these different challenges.
Thank you. Claire, Jennifer mentioned the rainforest and sort of turning the tables here, that looking at the corals as a rainforest that is at least as important as the rainforest above ground. So in terms of narrative, storytelling, how can we sort of turn these tables and make coral reefs as popular to support as the rainforest has been for many, many years?
That's a very good question. So, I mean, everything's obviously all interconnected, right? And that's the idea, is how can we communicate that's interconnection between all these different ecosystems, and also how we communicate that it's important to us as individuals, right? So it's making these projects through storytelling create kind of this vehicle that touches people's hearts as well as their minds. It's using storytelling and culture to I guess get further into those ideas of ecosystems. What are ecosystems? How do they work? There's a brilliant book called Blue Machine by Helen Chersky that I'm reading at the moment, and it's all about how the ocean is a machine. And it's a machine that has this very delicate equilibrium, and any slight difference in that machine will just, really create so much destruction, but it will ultimately come to us also. It will be a domino effect on us. And I think that way of communicating is really important. So talking about rainforests and the way that how the rainforest can connect with coral reefs, for example, how it connects with the oceans and how the oceans create the rainforest, in fact. It's the salt water that goes up and then goes into the rainforest. Exactly. So it's looking at it from that point of view of these are living things. They're not just things that we see on the surface of the water. They're not just trees. They are living beings. And that, for me at least, that is something that touches me personally. So hopefully it would touch audiences as well.
And this, of course, has an aspect of, well, maybe not gamification per se, but it's playful and interactive. How important is this aspect of making it almost like a game?
It's important because you need engagement. So something that's over 30 seconds long needs to be interactive and dynamic. So using sounds, obviously with this project, it was great because we had sounds, and I think that's something that we don't use enough. Projects that utilize that sense, and also the interactivity is important. Why? Because we use technology. We're a technology platform. So we live online. Everything is digital first, mobile first. So we have to create projects that obviously enable people not to be passive, but also engage on that interactive level, but not just interact with buttons and click here and there, but buttons that mean something and that have a result. And that's why we create these projects that are interactive, but they do end up being purposeful.
I was thinking of students when I saw your presentation here of schools. So how are you? Because that would be a wonderful collaborator, students all over the world, I guess. So how are you thinking of reaching the younger population? Is there any collaboration in mind with schools, the school system, for instance?
It's a very good question. These are things that obviously we think about. We have, classrooms online through our platform, so we have an educational element for young people. So there are, lots of learning hubs for all of our projects, and we always accompany as well our interactive experiences, so such as calling in our corals, with online exhibits where you can click and then be educated on coral reefs in general, and then we have interviews with the marine biologists, to go into more detail on what they're doing, what their work is. Also, we have street views, street views in coral reefs where you can actually see the coral reef in 360, which is quite amazing. So we do have these educational elements that intend to inform and accompany the experiences like this. And yes, of course, we're always open to thinking about ways that we can engage with more youth.
Thank you very much, Carol. Excuse me. Any thoughts from the rest of the panel in terms of engagement and me reaching, for instance, students?
Yeah, I'll weigh in. We spoke a lot about economic value, all the benefits these reefs give us. But as a small kid growing up in a landlocked area, I didn't care about any of that. What I cared about was the beauty, the sense of wonder, the sense of adventure that are coral reefs. And so that, I think the answer is what originally called me to start to protect reefs. The answer is staring us in the face. Coral reefs are amazing and engaging, even of themselves. So we need to share that. And I think what Google is doing of bringing people there, we were just talking about the street view aspects, that has such power to engage people and to encourage them, to motivate them to protect these incredibly important ecosystems.
Thank you. Jennifer, with your perspective from NOAA, and education, of course, is an element of this.
Yeah, absolutely. I'd build on what Ian would say, in that at the heart of conserving any of our resources is really about behavioral change in humans. When we say we manage fisheries or we manage corals, we don't manage those critters. We're managing our behavior as it relates to those ecosystems, to those organisms. So anything that we can do to instill a conservation ethic, a stewardship ethic in teeny tiny kids all the way up into octogenarians is going to be what saves the planet generally. So the more sense of wonder, the more appreciation for the beauty that we can instill in small kids. There's nothing like a little kid shaming their parents when it comes to recycling or anything like that, the better off that we'll be. And Ben hit on it. Citizen science is really important too. More people want to go have meaningful vacations where they feel like they're contributing. So coral reefs are a little bit difficult. It takes a lot of technical expertise to understand what you're seeing. And the more that we can simplify data gathering and sharing and getting information into the hands of managers, the better off we'll be.
Indeed. We're nearing the end of this session here, this beautiful session, and I look at you, Claire, and I see the coral behind you. It's so inspiring. And if you have ever been close to a coral reef, I've been fortunate to have been able to scuba dive at actually one of the COPs in Sharm el-Sheikh. And I was happy to see that the reefs were in pretty good condition in parts of the ocean and the Red Sea. So Carol, it's almost close to the thing you're protecting here, your name. What would you like to finish this session off with in terms of call to action for people to use this beautiful platform?
Yes, absolutely. It's to use the platform, it's to contribute, be a citizen scientist. It takes 3 minutes and the actual audio is only 30 seconds long. And when you click, that gets sent back to the marine biologist who then can analyze that audio for you. And it will help this restoration process. And also there's this educational element that I mentioned before on the platform. There's a page called Coral Chorus that gives you a lot more information. And as Ian said, it takes you right into the coral reefs. And one of the main things for us is also that we'd love people to go out more and see. You mentioned you went to the coral reefs in Sharm el-Sheikh. I also went there, and it was absolutely glorious. And I'd never seen coral reefs like that in my life. But I was privileged to have that experience and be able to be in that space to be able to do that. But anyone who can't travel, obviously, it's nice to be able to experience them as well online in a digital form, because it's important that we care.
Indeed. And who wouldn't want to be a citizen scientist? I for sure. I'm going. I'm going to use this platform and contribute. It was a beautiful session. And thank you again, Jennifer. Thank you, Ian, and thank you, Ben, and especially thanks to Claire for showing us this platform. And citizen scientists, that's going to be all of us, right? Okay, thank you. We'll be right back with another beautiful session here that is related to climate, of course. So stay tuned.